Namaste and welcome back to JEE Chemistry with Typical Monk. This is class 14, Electrochemistry, the first part, cells. Drop a strip of zinc beside a strip of copper, wire them together through a salt bridge, and something quiet and remarkable happens. Electrons begin to flow, and a spontaneous reaction becomes a battery. Today, we build the galvanic cell, measure it against the standard hydrogen electrode, read the electrochemical series, and predict a voltage at standard conditions and beyond with the Nernst equation, one idea at a time. Here is what you will learn today. First, galvanic cells, the Daniell cell with its anode, cathode, and salt bridge. Second, electrode potential, the standard hydrogen electrode whose potential is 0, and the standard EMFF. Third, the electrochemical series, reading oxidizing and reducing strength. Fourth, the Nernst equation, the EMF at non-standard concentration. And fifth, delta G standard equals minus NFE standard, the equilibrium constant K from E standard, and drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The galvanic cell. A spontaneous redox reaction drives a current. It turns chemical energy into electrical energy. The two electrodes. Oxidation happens at the anode, which is negative. Reduction happens at the cathode, which is positive. The standard electrode potential. It is measured against the standard hydrogen electrode, whose potential is defined as 0, and that gives us the electrochemical series. And the EMF E cell standard equals E cathode standard minus E anode standard. A positive value means the reaction is spontaneous. Now look at the picture. The Daniell cell built. The setup: a zinc rod stands in zinc sulfate, a copper rod in copper sulfate, and the two are joined by a wire above and a salt bridge below. The anode, the negative electrode, zinc is oxidized. Zinc goes to zinc 2 plus 2 electrons. Those electrons leave the zinc rod and enter the wire. The cathode, the positive electrode, copper ions are reduced. Copper 2 plus 2 electrons goes to copper, plating onto the copper rod. And the salt bridge. It completes the circuit and keeps each half cell electrically neutral. In the external wire, electrons flow from the anode to the cathode. Now, how do we put a number on the drive to react? Through the electrode potential. The ribbon holds the anchors. The standard hydrogen electrode at 0, the EMF as a difference, and the free energy. Electrode potential. It is an electrode's tendency to lose or gain electrons. And here is the catch. We can only ever measure a difference, never an absolute potential on its own. So we fix a universal 0. The standard hydrogen electrode, platinum, hydrogen gas at 1 bar, hydrogen ions at 1 molar, and its potential is assigned exactly 0. The standard EMFE cell standard equals E cathode standard minus E anode standard. For the Daniell cell, that is 0.34 minus, bracket, minus 0.76, which is 1.10 volt. And the cell notation, anode on the left, zinc, bar, zinc 2 plus, double bar, copper 2 plus, bar, copper. The double bar is the salt bridge. Let us work the G favorite. The Nernst equation, the free energy, and the equilibrium constant, all from one cell. Take the Daniell cell with zinc ions at 1 molar and copper ions at 0.01 molar. The cell first. E cell standard equals E copper standard minus E zinc standard 0.34 minus, bracket, minus 0.76, which is 1.10 volt. 2 electrons transfer, so N equals 2. The Nernst equation. E equals E standard minus 0.059 over N times log Q, where Q is zinc ions over copper ions. Substitute. Q equals 1 over 0.01, which is 100, so log Q is 2. E equals 1.10 minus 0.059 over 2 times 2, which is 1.10 minus 0.59, equal to 1.041 volt. The free energy, delta G standard equals minus NFE standard, minus 2 times 96,500 times 1.10, which is minus 212.3 kilojoules. It is negative, so the reaction is spontaneous. And the equilibrium constant, log K equals NE standard over 0.059, 2 times 1.10 over 0.059, about 37.3. So K is about 10 to the power 37. The reaction runs essentially to completion. Now the picture that ranks every couple, the electrochemical series. The scale. These are the standard reduction potentials, all measured against the standard hydrogen electrode, which sits at exactly 0. Reading it downward, a more positive E standard means the species is more easily reduced, so it is a stronger oxidizing agent. Fluorine, at the most positive end, is the strongest oxidizer of all. The other end, a more negative E standard, means the species is more easily oxidized, so it is a stronger reducing agent. Lithium and zinc live up there. And predicting a cell, the couple with the higher E standard becomes the cathode. Then E cell standard equals E cathode standard minus E anode standard comes out positive, and the cell is spontaneous. Now what JEE actually asks. 5 pointers. 1. In a galvanic cell, oxidation is at the anode, negative, reduction is at the cathode, positive, and electrons flow from anode to cathode in the wire. 2. E cell standard equals E cathode standard minus E anode standard. A positive E cell means spontaneous, which means delta G standard is negative. 3. The standard hydrogen electrode is the zero reference. A more positive E standard marks a stronger oxidizing agent. 4. The Nernst equation, E equals E standard minus 0.059 over N times log Q at 298 Kelvin, the EM falls as the product ion concentration rises. And 5. Delta G standard equals minus NFE standard and log K equals NE standard over 0.059. A large positive E standard gives a huge K. Now an assertion and reason drill. For each pair, are both true, and does the reason explain the assertion? First pair. Assertion. The standard hydrogen electrode is assigned a potential of exactly 0. Reason. The absolute potential of a single electrode cannot be measured. Both are true, and the reason directly explains the assertion. We need a reference precisely, because absolutes cannot be measured. The answer is second pair. Assertion. In the electrochemical series, fluorine is the strongest reducing agent. Reason. Fluorine has the most positive standard reduction potential. The reason is true, but the assertion is false. A most positive potential makes fluorine the strongest oxidizing agent, not reducing. So the answer is D. Third pair. Assertion. A cell with a positive E cell standard runs spontaneously. Reason. The salt bridge keeps the two half cells electrically neutral. Both are true, but the spontaneity comes from delta G being negative, not from the salt bridge, so the reason does not explain the assertion. The answer is B. Now match each term to its meaning. The anode goes to oxidation, the negative electrode. The cathode goes to reduction, the positive electrode. The standard EMF goes to E cathode standard minus E anode standard. And the free energy goes to delta G standard equals minus NFE standard. 4 pairs, each worth committing to memory. Now, how many of these 3 statements are correct? 1. In the external circuit, electrons flow from the anode to the cathode. That is correct. 2. The standard hydrogen electrode has a potential of plus 1 volt. That is wrong. It is defined as exactly 0. 3. A positive E cell standard means the cell reaction is spontaneous. That is correct. So the answer 2 are correct, statements 1 and 3. The trap is statement 2. The standard hydrogen electrode is 0, not plus 1 volt. Now the 2 mistakes that quietly cost marks. The myth, E cell standard equals E anode standard plus E cathode standard. The truth, E cell standard equals E cathode standard minus E anode standard. It is a difference, and sign slips here are the commonest error in the chapter. The second myth. The Nernst factor at 298 Kelvin is 0.059 over NF. The truth. It is 0.059 over N. The Faraday constant is already folded inside the 0.059. So E equals E standard minus 0.059 over N times log Q. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The standard potential of the standard hydrogen electrode. 0 volt. By definition. Question 2. E cell standard if the cathode is plus 0.80 and the anode is minus 0.76. 0.80 minus bracket minus 0.761 1.56 volt. Question 3. Where does oxidation occur? At the anode. Question 4. The value of N for zinc plus copper 2 plus. Going to zinc 2 plus plus copper. 2 electrons. And question 5. The sign of delta G standard for a spontaneous cell. Negative. Let us gather it all in one breath. The galvanic cell, oxidation at the anode, negative, reduction at the cathode, positive, electrons, flow anode to cathode. The standard hydrogen electrode is the zero reference. The series ranks E standard, more positive, is a stronger oxidant. E cell standard equals E cathode standard minus E anode standard. The Daniell cell is 1.10 volt. The Nernst equation, E equals E standard minus 0.059 over N times log Q at 298 Kelvin. Delta G standard equals minus NF E standard and log K equals NE standard over 0.059. Next class, Electrochemistry, Part 2, Conductance, Gold-Rausch's Law, and Electrolysis. A galvanic cell turns a spontaneous reaction into a steady current. The anode gives up electrons, the cathode takes them, and the electrochemical series and the Nernst equation tell you exactly how much push. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you'll crack G. I will see you in the next class.